If by the end of this video you're still stuck trying to solve this implicit differentiation problem, then I would have failed you. So go ahead and leave the dojo, unsubscribe, kick your desk, doesn't matter. Let's go ahead and get started because I'm going to make this really easy for you. For this problem here on the left-hand side, because we have this quotient, I personally don't like working with that if I don't have to. So I'm just going to multiply both sides of the equation by x minus y. And you don't have to take that approach. Let me know below if you took a different step. But this is going to leave us with 5x equals x minus y, all times 2 plus x cubed. Now for the next step, if we're trying to solve for dy over dx, as you would expect, we need to take the derivative of both sides of the equation with respect to x. So on the left-hand side, for 5x all prime, normally we would say, oh, the derivative of 5x is just 5, right? And that's not wrong if we're talking about with respect to x, but hang on a second, because there's a reason why I'm leaving this as just 5x prime. Now for the right-hand side, I'm going to do the same thing, just leaving everything as prime notation, knowing that we have an application of the product rule here, because for x minus y, times 2 plus x cubed, we've got a product of terms. And if you remember, the product of terms AB has the derivative of a prime b plus ab prime. Okay, so now let's uncover this a bit more. You know how with 5x, the derivative with respect to x is normally just 5, right? What I want to do here for implicit differentiation, this is a method I like to use, and I've covered it in other videos like the one above. Whatever expression I'm working with, I choose the variable I see as the control variable. And what I do is I first take the derivative of the expression regardless of what that variable is, whether it's an x, whether it's a y, almost pretending like it's just a typical x, right? And then I'm going to multiply it by some term that's something over dx. And that something on top, in this case for 5x, is going to be dx. Because when I'm taking the derivative of 5x, that expression has x as a variable I'm treating as the control. Now you might be thinking this is silly because dx over dx looks just like 1. Why would you write that? And you're right. There's nothing wrong with this, but it's just a really good process I like to use if you've been stuck on these problems. So with this being said, dx over dx will go away when we simplify this expression because the rate of change of a variable with respect to itself is just 1, right? But the reason why I like this method is for the following reason. On the right-hand side now, this is where most of you get stuck. How do we take the derivative with respect to x of x minus y, where we have x minus y prime here? So remember, it's a difference of two terms, x and y, so you can take the derivative of each one separately and subtract them. Again, for the x term here, we're treating x as the control variable, take its derivative regardless of what that variable is, which would just be a 1, right? Times dx over dx, because in the top here, x is once again the variable of control. Now for minus y, I don't care if that y is an x or a y here. Take its derivative no matter what, as if it was respect to that variable. So for y, it would just be a 1, right? But then times dy over dx this time, because on the top here, we had an expression where we're treating y as the control. And then this is all times the original 2 plus x cubed. And then for the second part of the product rule, we've got plus x minus y. And then for the expression 2 plus x cubed, all that prime, same thing, right? The 2 term, I'm just going to not even leave it there because that's just going to be 0 no matter what. And then plus, okay, x cubed, take its derivative as you normally would. That's 3x squared dx over dx. And now for the next step, what I'm going to do is anywhere I see a dx over dx, I'm just going to get rid of them altogether, simplifying the expression to this, what you see here. And then what I want to do next at this part is for the right-hand side, I want to go ahead and just multiply through all the terms, right? Giving us 5 equals all of this on the right-hand side. Now by inspection, one thing I'm already noticing here is that I can further simplify this because I've got 2 terms here that have an x cubed, both this 1x cubed and this 3x cubed term. So I'm going to go ahead and combine those, giving me 4x cubed as the leading term in this expression. And then to take this further, I know I need to solve the problem for dy over dx. And I rearranged all the terms on purpose so that they're all grouped together similarly, so that on the right-hand side, the last 2 terms can just factor out dy over dx, giving me this expression. And also the other thing I did here is I subtracted 5 from both sides, giving me a 0 on the left, because ultimately I want to put dy over dx on the left-hand side by adding it to both sides. and trying to isolate that term so that I can get my final answer. Okay, so what I'm going to do next now is I'm going to do just that. I'm going to add dy over dx all times x cubed plus 2 to the left-hand side, giving me this simpler expression. And the one thing I really want you to remember that will help you not get stuck on these problems. Here, notice how on the right-hand side, we still have something with an y in it. Sometimes we get baffled and we spend way too much time on these problems in our exams thinking, I need to write everything in terms of x. But you don't have to here. This is an implicit differentiation problem. Oftentimes for problems like this, when you graph it, you'll even notice that it's not even really a function, but it's a relation, because a lot of these kinds of problems fail the vertical line test. So save yourself time. Remember this as a big takeaway from this video. It's okay to leave a y here in the final answer. And try it for yourself. Try writing y in terms of x and see how complicated the answer gets. So the last thing I'm going to do here is I'm just going to simply divide both sides by x cubed plus 2, getting dy over dx as your final answer. And for the next video, you'll want to make sure that